So now we're talking about systems of linear equations in three variables. Notice the difference from the previous lectures and the similarities. We're talking about linear equations still, but this time we're in three variables. So instead of having two linear equations in terms of x and y, now we're going to have three equations in terms of x, y, and z. And the easiest way to show you this is just to do an example. So example 1, and let's just say solve the system, and I'm just going to abbreviate by saying solve. And here is the system. 5x minus 2y minus 4z is equal to 3. That's one equation. 3x plus 3y plus 2z is equal to negative 3. Negative 2x plus 5y plus 3z is equal to 3. Alright, so that is my system, and I want to make sure that all my x's, y's, and z's are lined up, and the only thing on this side of the equal sign are just the constants that are all by themselves. So once I have this set up, or once you're given this, now we want to start a process. And the process will work the same for most of all of these. And the way we're going to do it is we're going to be using the addition method over and over again. We're going to use it several times, and eventually we'll get to a point where our answer will just pop out. So the first thing we want to do is we want to label, this is equation 1, and I'm just going to say 2, and this is equation 3. So the circle with the 1, that means that's equation 1. This is equation 2, and this is equation 3. So you want to start off by just taking equation 1 and 2. And you want to do the addition method on there and eliminate one of the variables. And then that's going to produce a new equation for us. And then we're going to want to take equations 2 and 3, do the addition method, and that's going to produce a new equation for us. And then from those two equations, we'll do the addition method again. So we're doing the addition method 3 times here, and it seems a little tedious and difficult, but once you do a couple examples and you see one, it's not too bad. You just need to make sure you can understand and follow the process. So what I want to do, or what we want to do, is start with equation 1 and equation 2. All right, and let's just write what those are next to here. So 5x minus 2y minus 4z is equal to 3. And then here I'm going to write equation 2. Alright, so now I want to do the addition method. I want to eliminate one of these variables. And so which variable do I want to eliminate? Well, the easiest one to eliminate would be z here, because all I have to do is multiply this bottom, this equation 2 by negative 2. So if I multiply equation 2 by negative 2, this becomes negative 4z. So let's try it out. So we draw a line like this, and then we write what we're doing to change it, and we draw another line and we write what we're doing to change it. So we're not changing anything on the top, so there's no change here. And on the bottom, we're going to multiply the entire thing by 2. And I said negative 2 earlier. I should have said just 2. Multiply by 2. And as long as we do that to both sides of equation 2, then we haven't changed the equation. So the resulting equations are this. So let's write what hasn't changed first. Equation 1 didn't change, so let's just rewrite it. And now, equation 2, we're multiplying each term by 2. So 2 times 3x is 6x. 2 times 3y is plus 6y. And then 2 times 2z is plus 4z. And then 2 times negative 3 is negative 6. right? So now that we have, now that we've almost eliminated this variable z, the way we actually eliminate it is by adding both equations down. So adding all the like terms together. So when we add down, we get 5 plus 6 is 11x, plus 4y, plus 0, which I'm just not going to write, and then add this down gives you negative 3. All right. So this using equation 1 and 2 and doing the addition method, we eliminated the z variable, and this gave us a new equation, and we'll call that equation 4. All right. Equation 4 is going to come back to play here in a minute. So what we have to do now is we used equation 1 and 2. Now we need to use equations 2 and 3. So we'll write equation 2 and equation 3 here. And let's just write what those are. And then equation 3 is negative 2x plus 5y plus 3z is equal to 3. All right. And it's the same process again that we did up here. I encourage you to pause the video and give this a try yourself. All right. So we don't have a choice here of what variable to eliminate. We have to eliminate z. The reason we have to eliminate z is because that's what we did up here. When we do that, we'll wind up with another equation. We'll call it equation 5 when we get there, and it will be in terms of only x and y. So now we've reduced this big thing down to a system of 2 variables. All right. So to eliminate these z's, I need to find a common value here. What can I multiply to these z's so that way they'll cancel out? All right. So the top, if I can say 6. That's what I'll say. I can change both of these to a 6, and I need one of them to be negative. So to make this 2z a 6, I need to multiply, let's say, by negative 3, because one of them has to be negative. Multiply by negative 3. In the bottom, to make this 3z a positive 6, I need to multiply by 2. And then you write the resulting equations. All right, so the top one, we multiply each term by negative 3. 3x times negative 3 is negative 9x. And then 3y times negative 3 is negative 9y. Negative 3 times 2z is negative 6z, which is equal to negative 3 times negative 3, which is a positive 9. All right, maybe someone just do this so we don't get too confused. All right, and then move on to the next equation. We multiply each term here by 2. Negative 2 times 2 is negative 4x. 2 times 5y is plus 10y. And then 3z times 2 is plus 6z. And then 3 times 2 is 6. And you see, we got what we came for. We wanted to eliminate these z's, and we did that. So now we want to add these down. So when I add the terms down, I get minus 13x plus y, and then these z's become 0, and that's equal to 15. That is our next new equation, and we'll call that number 5. So now what we want to do is we want to take equations 4 and 5. And notice that they are a system of linear equations in 2 variables. We started with a system of linear equations in 3 variables. We did the addition method twice, and we ended up with a system of linear equations in 2 variables, which is something that we're familiar with. So now we take these 2 equations and we do it all over again. Let's do a little squiggly line here so we can keep things separate. So equation 4 and equation 5. And let's just write them in here. 11x plus 4y is equal to negative 3. and then we have negative 13x plus y is equal to 15. Alright, I encourage you to pause the video and try to eliminate, let's eliminate the easiest variable here, and that would be y. So go ahead and pause the video and try to finish it out, or at least eliminate the y variable. Alright, continuing on, so to eliminate the y variable, I have a 4y here, and I have a plus 1y here. So I need to make this 1y into a negative 4. So when I add these y's together, it becomes 0. So I need to multiply equation 5 by negative 4. So the top has no change. And the bottom, multiply by negative 4. And our resulting equations are, the top one stays the same. Now multiplying each term in equation 5 by negative 4. When I do that, I get negative 13 times negative 4, which is positive 52x, and then plus y times negative 4 is minus 4y, and that's equal to 15 times negative 4, which is negative 60. Now we got what we came for. Our y's can be eliminated once we add down. So when I add 11 and 52, that gives me 63x. This is 0. And when I add this, this is negative 63. Divide both. So I'm just going to rewrite this so it looks a little cleaner. This is 63x is equal to negative 63. Divide both sides by 63, and out pops your x value. X is equal to negative 1. Alright, we're not done there because we have our x value. Now we need to determine the y's and the z's. So we're almost on the home stretch. The tedious part's over with. So now we just need to figure out our y and z variables. So we have our x. We can take this x and we can plug it into either equation 4 or 5, and out will pop our y value. The reason I'm choosing to plug x into equation 4 or 5 is, notice, I plug negative 1 in here for x, then I'm left with only y, and out will pop my y value. And now I have x and y, and I can take those values and plug them into any one of these three equations, and out will pop our z value. Alright, so see, I'm going to say take 5 and plug in x equals negative 1, just to kind of write out what I'm doing. So I found my x value, and I'm picking one of these to plug in that x value. So I picked equation 5. So let's write equation 5 here, just so I don't make any mistakes. And then let's plug in negative 1 for x. Negative 13 times negative 1 plus y is equal to 15. This becomes 13 plus y is equal to 15. Subtract both sides by 13, and you get y is equal to 2. So now I know x is negative 1 and y is positive 2. So now I need to come back to any one of my original equations, and I plug in my x value and I plug in my y value. And notice when I plug those in, I'll be left with z only, and out will pop my z value. We're going to have to go to a new page for that. I'll leave. Alright. So let's pick one of these equations first. Let's just pick the top one. So I'm going to pick, I'll write what I'm doing. Take 1, plug in x equals negative 1 and y equals 2. So let's write equation 1. And now I'm going to plug in my x and y values. 5 times negative 1 minus 2 times y, which was 2. minus 4z, which is what we're solving for. Simplifying gives you negative 5 minus 4 minus 4z, which is equal to 3. Add these together gives you negative 9 minus 4z is equal to 3. Add 9 to both sides. That gives you 12. So negative 4z is equal to 12. And then divide both sides by by negative 4, and you get z. So z is equal to negative 3. So your solution, the solution is negative 1, 2, negative 3. And then, of course, you want to check it. We're not going to check it here due to time restraints. All right, that's it.